Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contests. This is a grade 12 math Euclid contest question, and in it we have 3 parts, culminating in part C, where we have 3 lines that all intersect at a single point, and we need to determine the value of m. You can give them all a try. You can skip to the solutions in the chapters menu in the timeline, or you can wait a moment and I'll be right back with all the solutions. Alright, so let's start with part A. Now in part A we have to substitute x equals 11 into this expression to determine its value. But there's actually an easier way to do it. What we can do is realize that we can factor out a 3 in the numerator. So this would be equal to 3 times x plus 2 divided by x plus 2. And then as long as x does not equal negative 2, which it doesn't, it equals 11, then we are good to cancel x plus 2. And we can see that the expression will be equal to 3 for any value of x where x does not equal negative 2. Moving on to part B, we want to find the y-intercept of the line that passes through these 2 points A and B. Now the equation of a line is equal to y equals mx plus b, where m is the slope and b is the y-intercept. So we want to solve for b in this equation. Well, let's first solve for the slope. Now the slope is equal to the difference in our y-coordinates divided by the difference in our x-coordinates. Or put another way, rise over run. Now it doesn't matter which coordinate you choose to be 2 and which one you choose to be 1. I'll start with the coordinate b. So y2 will be equal to 7. Minus y1 would be equal to 5. All divided by x2, which is 1, minus x1, which is negative 1. So when we do that, we get 7 minus 5, which is 2. All divided by double negative is a positive, so 1 plus 1, which is 2. And so our slope is 1. So now we know that y equals x plus b. So I can choose either of those coordinates to substitute them in for x and y, and then I'll be able to solve for b. So let's do b. So y equals 7 and x equals 1. And so solving for b, we get b equals to 7 minus 1, or 6. So our y-intercept then is the coordinate 0, 6. Finally, part C. So here we have the equation of a line. Let's call it equation 1, and another line, equation 2, and another line, equation 3. And they all intersect at a single point. Well, let's look at the first 2 equations then and figure out what that point is. So if we equate our y's, then we end up with 3x plus 7 is equal to x plus 9. So let's rearrange this and solve for x. So we'll collect like terms. So we have 3x minus x equals to 9 minus 7. So 2x is equal to 2, and therefore x is equal to 1. So the point of intersection has an x-coordinate of 1. If we substitute that back into either equation, I'll do equation 1, we get y equals to 3 times x, where x is 1, plus 7. So y is then equal to 10. So our intersection point is 1 and 10. Knowing that's the intersection point, we can substitute this into our equation 3 to figure out what the value of m needs to be for this to be true. So here we have y, which is 10, equals m times x, which is 1, plus 17. Alright, so I'll bring 17 to the other side of the equation. So we have 10 minus 17 equals to m, and therefore 10 minus 17 is negative 7. So m equals negative 7.